Hey guys, what's up? This is your friend Maynard from Civil Center and I welcome all of you back to our channel and another video on civil engineering. So this is one of our sites at which the excavation work has been completed, and also the sand filling part and the PCC part and the marking of the columns have been completed, as you can see here. And also they have also completed the reinforcement binding for the footings as well as the columns. So the next step is, as per the structural drawing, we want to do the casting. So the first step was clearance of the site, which was completed, and the second step was your marking of the boundaries of the plot, and the third step was the marking of the footing positions, and after that excavation, and after the excavation sand filling up to 100 as you can see here, sand filling up to 100 after that 75 of PCC or the plain cement concrete, and after that the column positioning was done. So the column positioning was done, and after that the reinforcement binding of the footings as well as the columns was carried out. So after all these steps are carried out, the next day we want to go for the casting of your footings. So you can note, since they are eccentric footings, along with the columns along with the footings you also have a beam which connects the various footings. We'll also show pictures of it once we go to the site, and we'll upload a video of the pictures of the casting process as well. So for today's video we'll show you how to calculate the quantity of materials which will be required here, because you have to tell to the client that how much bags of cement, how much meter cube of coarse aggregate, and how much meter cube of sand will be required, so that he can procure it and we will be ready for this project. So this is a common and a very ordinary skill which is required for every civil engineer who wants to do site inspection or wants to do PMC or project management in future. So let's get started and we'll start here. So we have prepared an Excel sheet, simple Excel sheet, just to begin with for this video, and we have the structural drawing, and I'll explain how you can create this sheet and calculate the footings. So first of all, in this we have to look in this footing layout, because these footings will be casted. What are the types of footings which you have? So if you just look into our footing schedule, we have 6 type of footings. So I have just in the serial number 1, this will not be earthwork. Let's do this basic concreting. So just simplify this to concreting, and this is the number, and this is the length and breadth, and this is the height, which is the depth of the footing, and quantity. It will be the multiplication of these 3, and then units will be in cubic meter. So this will be the units here, and for the footing beams also we can do similarly. We'll just since they are of the same size, we'll just insert the length here and the breadth and the height, and after that we'll get the quantity, and after that we'll also find out the quantity of cement, sand, and coarse aggregate, and also the cost of the materials in this project. So we'll go one by one. It's very simple, but we need to do this properly. So first of all, we'll find out the size. We can write the sizes of these various footings here. So the size of this F1 is your 2000 into 2000. So they can write the area directly. It is 4 into 1 2 3 4 5 6 zeros, and we are working in meters here. So it means here it is 2 meters into 2 meters, which will be 4 meter cube. So we'll just write 4 here, and for the next size, as you can see, it is F2. So what we can do is we can just multiply this 2 sizes, 1800 into 1800 into 2000. So this will be 1.8 into 2.2. If we do this in meter, equals to 1.8 cross 2.2, just 1. Okay, we'll just 1.8 cross 2.2. Okay, we're done here, and the next part is F3 size is 2.2 into 2.2, so equals to 2.2 cross 2.2, enter. And the next size we can merge them, so that we'll have a better view. So we can simply click on merge and center. That will do. Okay, one by one we'll be selecting them and merge and center. Okay, So in this one we'll just 1.5 into 1.5, this one 1.5 square, and the next one area is 1.4 square equals to 1.4 square, and the next one is your 1.8 into 1.5. So the next one is 1.8, cross 1.5, 2.7, and we will also type the heights here. So the height we have, this is 0.45, so we are going with the heights equals to 0.45, and another 0.45 we have for these three. We'll just copy this, and here we'll just paste them, and equals to 0.5, copy them and paste them here. So we'll just now find out how many F1, F2 and F3 we have. So F1, we'll just search here for F1. So we don't have any F1 here, F1 here. We have 2 F1 in the beginning. So this will be 2. And for the F2, let's find out how many F2 we have. 1 F2, 2 F2, and then 2 F2 will have. So 2 F2, and the F3, let's see, check how many F3 will have. So we don't have any F3. 1 F3, 2 F3. Okay, 2 numbers of F3 will have 2 numbers of F3. F4, so F4, let's check how many F4 will have. 1 F4, and after that 1 F4, let's check, this is another F4, 2 F4s. So we don't have any more F4s here. So 2 F4s to go, 2 F4s. Let's take F5 and F6. So this F5 and F6. Okay, so looks like we have 2 F5 and 1 F6, and 2 F5 and 1 F6. So we'll just add the total number of footings which you have, and we'll just use a sum command, and just enter. Just take 11 number of footings here. So we'll check 1 2 3 4 5 6 7 8 9 10 11. So we are good here. So this is a way to cross check the number of footings also. So we have the length and breadth multiplied by height, and multiply the number of footings which you have, and this is the quantity of concrete which you get. So next is the footing beams. So as you can see, these 3 sides almost we are having eccentric footings, so that's why we are having this footing beams. So now this footing beams goes inside the footings. So the inside parts we don't need to calculate, because already this is included in the particular your footing. So the part which is outside, we'll just calculate that value, and we'll just, what we'll do is we'll multiply the length. The sizes is the same. The size of this particular beam is your length will be different. The size is 0.25, 250 into 300, this is the size. 25 into 0.3, this is the size, and the length, we'll just add all the lengths which we find from here. We'll just add the lengths. I'm just doing this one, and from here to here basically, and from here to here, there also, and here also, last but not the least, there. So now we can add them to get the the value of the lengths here equals to, so simple it is, 0.646 equals to 0.646 plus your 2.653. So we'll go with 2.653 plus, and this is 3.454. So this is 3.454 plus, next one is your 2.805. This one will be 2.805 plus, we'll go with 2.535 plus, and this one will be 3.261. So this one will be 3.261 plus, okay, we'll just continue this, 3.261 plus and here 3.353, so this will be 3.353 plus, and the next one is 0.996, so this will be 0.996, and this is the size which you have here, and I will just use a multiply command here, this cross, or else we already have a command here, we'll just type 1 here because okay. So this is done, this is multiplication of all this, and it is done. So here we also have found the quantity of concrete which will be utilized in the footing beams. So we have taken 5% extra. Generally you can this is the percentage of extra which you can take in concrete. I am going with, let's say, 6% extra to just to be safe here. This is the sum of all this, and multiplied by 1.05, I am doing this 1.06, that will be 6%, so I am taking 6% extra. So we have this cubic meter of concrete which will be used. So this is 12.99, almost 13 cubic meter of concrete. So now so this is the quantity of concrete, so this is 20.01. so this is the quantity of concrete, that is the volume of the concrete, which is the weight volume. And now if you want to find out the dry volume of concrete, we can also find out the dry volume of concrete by multiplying it. We just multiply it by 1.54, we'll able to find, so this will be this value multiplied by this value. So what happens, generally the weight of the dry volume of concrete is your more, because when water is added, then the volume this volume becomes less. So that's why we want to always multiply 1.54 along with the wet volume to get the dry volume. So this dry volume include the weight of the cement, sand and coarse aggregate. So we are going to use M20 grade concrete in the project here. So M20 grade concrete means 1 part of cement is to 1.5 parts of sand or coarse aggregate is to 3 parts of your 1.5 parts of fine aggregate or sand and 3 parts of your coarse aggregate or your stone chips. So here we'll just find out the quantity of cement here. So quantity of cement, this let's find out first in your let's say cubic meters. So this, if we add this, if we add this 1 plus 1.5 plus 3, I'm just adding for just showing you, 1 plus 1.5 plus 3, it will be 5.5. so the the quantity of concrete, if we find out, it will be equals to 1 divided by 1.5, sorry, not 1.5, 5.5, 5.5 and 5.5 cross and multiplied by, this will be multiplied by your the total volume, total dry volume. This will be the cubic meters of concrete cement which will be used. So we also know that the unit weight of, just write CUM here, the unit weight of your cement is 14440 kg per cubic meter. So this is the unit weight of cement, standard unit weight of cement. You can Google it out. And after that, using this we can find out the total weight of cement. So the total weight of cement will be equals to 5.6 cubic meter into the unit weight. This will get us the total weight of cement. So there is some error here. So we have written the units here, that's why I'm just erasing that, and that will get the proper value. So unit weight, let me write it, the unit here in kg per C1. Okay, we can write it here. So this will give the unit weight of this will give the total weight of your cement used. So now if we want the number of bags of cement used, so here we can write here total cement weight, and here let's write number of cement bags. So this will be this value divided by your 50, because one bag contains 50 kg of cement, so approximately you can take as 162 bags of cement. Okay, so you can just use the round up command to just have a round up command to have a uniform value here, 162. Okay, so next is where we can bold this, because cement we are going to purchase in bags. So this is the total the gray, so total bags of cement which we need to purchase for this particular works. And for the sand here, now for the sand we'll just use the same this formula for the sand and coarse aggregate as well. Just what we'll do, let us increase the size here. What we'll do is we will take this as, this will be 1.5, so this will be 1.5 into divided by 5.5 into this, will not be G14, this will be actually G13. So this will be it, and this will be, if we can copy this, and 1.5 into 4.5 into G13. So this will not be 1.5, instead it will be 3 divided by 5.5, because this is the ratio of the coarse aggregate. So this is the fine aggregate, this is 1.5 times 1.5 by 5 times, this is coarse aggregate, this is a 3 by 5.5 into this one. So this is the volume of the coarse sand and the coarse aggregate. So as you know, the cement comes in our bags, the coarse aggregate comes in our trucks or lorries, whatever you can call it, and the average capacity of a truck is 14 to 16 meter cube. It may come in less or it may come in more depending on the size. So the sand costs around 5,000 for one truck, or 5,000 for 16 meter cube. So if the cost of 16 meter cube is 5,000, so you can find out 1 cubic meter of sand costs. The sand and the coarse aggregate comes in the unit of trucks or the lorries, and they take the money also in that. I'm just finding out what 1 cubic meter will cost. So it will cost your 5,000 by 16. This is simple using the unitary method. So it will cost around this much, and if you can see here, it will cost around this much. If 16 meter cube costs 5,000, 1 meter cube will cost this much of sand, and similarly 1 meter cube of this aggregate or aggregate costs here, already we know 1450 per meter cube. This is the cost of the aggregate here. So if you find out the cost here, so it will be in INR. If you find out, this value calculation is in the Indian rupees. So here the cost of the cement bags will be 162 into, if you go for 315 rupees per bag. The cost varies according to season. So currently the period which I am making the video, Ultratech PPC cement, this is the rate of it. So this is around 51,000 for this this bags, this number of bags, 51,000. And for the sand, it is the cost will be your, this will be the cubic meter of sand here, and it will be multiplied by 1 cubic meter of sand cost. This will be around 2,600 rupees, and this is the quantity of aggregate here. If you multiply it by the cost here, so it will be around 24,000. So this is the cost of the materials which will be used in this project. So now we can procure this many bags of cement and this amount of your sand and the coarse aggregate for this particular project, so that this project goes smooth. So if you got to learn something from today's video, do share with your friends, and this really supports us a lot. And also, if you want to avail of courses from us related to the various fields of civil engineering, you can check out our description related to exciting courses on design using various softwares like Tekla Structural Designer and many more. Bye bye, that's all for today's video. Keep learning.